it's a term, and so what are some of the definitions people use? And then I'm going to explain a little bit about this idea called machine learning, which is probably the what most people use AI. When they say AI these days, it's often describing machine learning. AI has been around for quite a while, but just recently, this technique for doing artificial intelligence called machine learning has become very popular and done some things that traditionally people couldn't do with the older fashioned approach. So I'm going to try and kind of explain a little bit. You can impress your friends, be like, oh, do you know the difference between AI and machine learning? Hopefully that's what I'll convey there. And then I want to jump, really quickly into a discussion and ask a couple questions to you all, and spark a conversation around AI that touches upon the topics you are most interested in, because it's a big field and there's a lot we could talk about, but there's a few things we really should talk about, which are the things that are of interest to you. Um, so yeah, that's the overview. Without further ado, I am Luke Merrick. I live in Mountain View, California, which is kind of the heart of Silicon Valley. The headquarters for Google is just down the street. I work at a startup called Fiddler, and here's our big tagline up here on the top of the page. You can see we're about kind of understanding and trusting and explaining AI technologies. Um, my work typically involves a little bit of both things on the bottom. So on the left, you see some code and some graphs. On the right, it's a lot of whiteboarding. Um, that's kind of what it means to work in AI these days. Is this computer code you're writing? It's numerical, basically having the computer do a bunch of math for you and then looking at the output in little pictures. And then it's thinking about the math that went into all of that at a whiteboard or a blackboard or pen and paper, very kind of low tech actually. A lot of math or theory goes into this field these days.
Excuse me.
Moving back to, sorry. So for those of you who are not looking, don't worry. A lot of these pictures are for me to make sure I stay on track. I will soon just get to a conversation, but for those who can see it, hopefully it adds a little bit of interactive audio visual experience. So this is my work. This is my background. I put this out there because hopefully we'll have a nice discussion and you guys can ask me about, particular things. What's it like? What are AI startups like? What's the difference between big company AI and small company AI and stuff like that? I'm happy to get into any of these conversations. But really this talk is about AI and not me. So I'm going to go through kind of two definitions. I put quotes on the word definitions here because these are quotes from famous computer science people, and they're kind of one is more of a joke than an actual kind of real attempt at a dictionary definition. But I think that these two perspectives are very helpful to understanding what people should be talking about AI. A lot of people talk about, AI is going to do this, AI is going to do that. That's kind of like saying my car is going to drive to the store. It's not. AI is a technology. It's a thing. It's not really a person. And so we have to really think about what it is as an object and how it's going to be used. And so the first definition here, and this is maybe the most visually interesting thing. I don't actually know what this picture is quite trying to depict, but this is Marvin Minsky. He's one of the founding fathers of the field of artificial intelligence. He co-founded the Massachusetts Institute of Technology's AI laboratory. And he and others of his era tended to use this type of thinking. This is, I think, back in like the mid to late 50s, 60s, when computers were first being, romanticized as the beginnings of trying to play chess were starting to happen. Checkers was moving to computers, and by the 70s, 80s, and by then they were built on the techniques pioneered by men like Marvin Minsky. And so his quote here is, "Artificial intelligence is the science of making machines do things that would require intelligence if done by men." And so there's a couple things to call out here. He's defining artificial intelligence as a science, not as like an object, so much as it's a technique, a technology. And the goal is to use machines and do things that would be hard to do. And so uh, this is something to keep in mind, that artificial intelligence is not necessarily about making a robot human, making a C3PO from Star Wars that you can talk to. It's more about doing things that would require intelligence to do normally, that are hard for us people to kind of just build a machine. You can build a tractor to plow a field, and you don't need necessarily intelligence to plow a field. You need strength. We domesticated animals and built steam powered and gasoline powered machines to do these things, but there are certain tasks that would require kind of a human thought process. Like, how do I actually understand visually where the blocks are, and I have to think about where to put this block on top, and that requires kind of some sort of intelligence to do. So that's kind of this is more the formal and old school definition. I think it's important to realize that this is just one way of looking at it, and my favorite definition actually comes from Larry Tesler. Um, Larry Tesler is famous for inventing copy paste. So if you've ever copied and pasted text onto a computer, you can thank him. Before he came around, you had computers were even harder to use, if you believe it or not. He actually was a pioneer in making computers more user friendly. It's unfortunate that he's no longer with us because computers are still very hard to use. But he did some great work getting us some improvements. And he quipped that intelligence is whatever machines haven't done yet. Um, and I love this definition, because I think this, when people get confused about what AI is, it's because other people are talking about AI in a very, 10 years ago, AI was different than today's AI. And it's not because the technology is that different. It's because, we've done things with AI. And so then those things no longer are AI. Put another way, as soon as somebody solves the problem, it is no longer intelligent. Um, and so, to kind of unpack this, I want to discuss some history. Now, I'm not the strongest student of history. I was an engineering student. I studied more math and science. But a couple facts about what machines are may be interesting to you all. And so this is the most history I'll get into today, unless you really probe me in the questions. But um, this piece considers two terms that we use to refer to machines. From going back to Marvin Minsky's definition, we science of making machines do things that would require intelligence. Um, well, it's funny, because the things that we consider machines today, computers and calculators, are actually those terms, for most of their existence, referred to people. And that's right. There were back in the day, and I'm talking the 1700s and before. Um, you know a calculator was just somebody who knew their times tables, or they knew to add and subtract. And so they would get hired by some merchant or something to kind of help uh, tally up things and do math. Or later, computers were people who actually could compute complicated things with the slide rule and do trigonometry, and were hired by the United States Geological Survey and stuff like that. If you go find an old newspaper from before the invention of of electronic computers, um, you can find job postings for computers, who are people who have taken college math classes, who will by hand, using tables and slide rules, do all of this math. And so we think, I don't know, show of hands, how many of you have used a calculator before? I've added two numbers together by punching in buttons. Probably most of us will put our hands up and say, yeah, I've used a calculator. Um, what's interesting to realize about that is that calculator itself is artificial intelligence. For gosh, before the 1700s, we didn't have mechanical adding machines. And so from the 1300s through the 1700s, in that era, um, that was a human intelligence, was adding numbers. You had to go to college to learn your times tables far enough back. And you know um, it was before when it was all Roman numerals. If you ever tried to do multiplication with Roman numerals, I mean, I'd want a college degree for it. That's hard. um, and so all of that, that intelligence that people used to have, has over the years, over the centuries, been wired into these machines, and we've used them so much that we stop thinking them as intelligent. Sure, if you have kids and your kids learn to do multiplication, you're like, heck, my kid's intelligent. But the minute you pick out, your pocket calculator, that's no longer intelligent. That thing is just a machine. And so, um, it's interesting to realize that this term AI is really, in some ways, it's just a moving target that we can never hit, because as soon as we hit it, um, that thing that we just hit is no longer intelligence. Adding numbers is no longer intelligence because a computer can do it. Um, Winning chess is no longer intelligence because a brute force algorithm can beat people. All of these things have happened, and as they continue to happen, the history has shown us that people stop calling that intelligence, and we move the goalpost. So over the 500 600 year era between human calculators to mechanical adding machines to the ENIAC and the first electronic calculators, people slowly moved from considering that intelligence to considering that mundane. um, there is, this is not all to say that nothing's changed and people are just rebranding stuff. There have been a lot of technological advances, and one of the big ones here is this idea called machine learning. And the thought here is, we're doing all this AI stuff to make computers do things that we'd have to do because we're lazy. We don't want to do it. We don't want to sit there with a pen and paper and do multiplication. We're going to have a computer do it for us. We don't want to sit there and decide what stock to buy. We're going to have a computer do it. Um, Machine learning is the epitome of laziness, where we say we don't even want to write the AI program ourselves. We want a computer to do it. So we're going to write one program one time, and that program is going to go. And this is not 100% accurate. There are many programs written to do machine learning. In fact, people probably have spent more time on AI thanks to machine learning than they've saved, because it's so exciting, and the potential is high that people are investing a lot of effort into it. But good old-fashioned AI, which is actually an acronym, GOFAI. If you go on Google, you can find all sorts of definitions for that. The idea is that you write down in computer code a set of rules, or some equation that it works as rules, which transforms data, transforms inputs. Maybe the data is the position of every piece on a chessboard, and you write a rule that says, okay, tell me what the next move to make is for white when you give me the input, the data of the chessboard, and then I give you that decision. I'm gonna tell you, okay, move my knight to this square. Machine learning is this idea that we can actually have an algorithm that takes in both the data and the decisions. So, we record what a person did. You look at a bunch of chess games, or you look at, you know, uh, you take a bunch of recorded, if you ever use Alexa to your voice assistant, you take a bunch of recorded conversations and you have a person write down what the decision, what the actual text was. So you say, okay, I'm gonna get a microphone. I say, Alexa, turn on the radio, and then I write down in text, Alexa, turn on the radio, and then I can feed the data, the sound plus the decision, the turn on the radio information, into an algorithm that will give me the rule. And this is very interesting, because sometimes it's very hard to write the rules. Um, it's very hard to write computer code that takes in audio, just sound, and outputs decisions for what am I going to turn on the lights? Am I going to turn on the TV? Am I going to tell you the weather? You know, it's very hard to write that as a rule, but it's possible to collect a lot of data very easily. I can just, I go up to 10 people and I say, here's a recorder. Can you just say, Alexa, turn on the lights? Just say that 5 times, and we can just collect all this data. And so machine learning is this idea that in an era of big data and a lot of, computers are very good at collecting and storing data, we can use all of this data to help us create the rules. If we can record both the data for the inputs along with data for what people have done as the true correct decisions, we can have a computer infer the rules from that collection of data decisions. And so to give a few more examples of what machine learning is used today to do, um, a lot of breakthrough technologies come in terms of computer vision, so understanding images, and that can be as simple as labeling the the category of an image. Is this a dog? Is it a cat? Is it an outdoor scene? Is it an indoor scene? If you ever use Google image search to go find pictures of things, they're starting to use more and more computer vision to actually understand what's in pictures and label it. So when you search for it, you can find a picture with that content. And then there's also a lot of breakthroughs in natural language processing. So understanding a lot of recent headlines have come from this machine learning based model that has gone through more words than you will ever read in your lifetime and looked at the words that are next to it. So it's read the entirety of Wikipedia. Like we're talking uh, so much text written by people, and it has learned to predict the next word in a sentence. So you give it 10 words and it will tell you what the 11th one is. And with that, you can repeat that process where you give it 10 words, it predicts the 11th. You give them 11 words, it predicts the 12th. And pretty soon you have a machine learning model that's writing. And this is called GPT-2 is the model. You can Google it. But there are a number of these now. These things, it's very hard to write rules that will generate, text. If you've ever taken an English class, they tell you a bunch of rules, and then you read a book and it breaks all the rules. They say I before E except after C, and in 10 of these other words that there are no rules in. And so that makes it very hard to write computer code rules that will do things with English. But when you have enough data, the machines can actually learn the complicated rules and the complicated patterns and the exceptions to the rules themselves from the data. And that's what machine learning is doing. And there are a number of technologies for it that have arisen in recent years. Self-driving cars use machine learning based models to understand video of what's around and find where pedestrians are or read stop signs in pictures. And that technology is very hard because if you wrote a rule that said, okay, here's a picture, can you describe in a simple, rule actually how to map, a 1,000 different colors, all the pixels of an image, because it's a bunch of squares of one color. Can you map that into, is this a stop sign or not? Very hard, but a computer can actually learn to do this when you give it enough examples of what a stop sign is and what a stop sign is not. So this is machine learning. This is kind of the complete bit of the introduction to our today's talk and discussion I wanted to give. As just a quick recap, we started talking about my background. I work in Silicon Valley at an AI company. We're trying to help people understand their AI better. We talked about two definitions. We had Marvin Minsky's definition of artificial intelligence as the automating things that require human intelligence if we didn't have computers. And then we had Larry Tesler's joking definition that intelligence is whatever machines haven't done yet, and that as soon as you actually as soon as your AI technology makes it so that a machine can do that task, it's no longer intelligent, and that artificial intelligence will never be achieved. And those two perspectives brought us into this feeling that maybe nothing's changed. We then talked about, interesting that computers and calculators actually used to be people's jobs, and that, maybe Larry Tesler's right, to machine learning, this new technology that's really picked up steam in the last decade or two, that has kind of said, well, maybe Marvin Minsky is right, that we're able to actually do some things that we think are pretty darn intelligent, like, winning at board games, or telling you what's in a photograph, or writing text that looks like a person wrote it. And so these are a bunch of ideas I wanted to kind of throw out there. And then in the next bit, I just want to move to hearing questions from you all, and answering questions talking about any particular topics in AI that are interesting to you. So I have a couple prompts here, but feel free, if there's anything that you've just been thinking about, you hear the word AI and it makes you think about something, shout it out, raise your hand, let me know. And for those who can't see the questions written out, it's just a list of 4 questions. How do you view AI? What applications of AI technology are you most interested in? What scares you about AI? And what kind of AI inspires you? Those are just some ideas here. I find AI scary, inspiring, and interesting. That's why I chose to work in it as my career. So hopefully we can have a nice little discussion here.
And Luke, do you want to stop sharing the script. Perfect. And then we can all see one another. Yeah,
Yes.
perfect. Okay, so if I see a hand up, I'll call on you, and then you can ask your question. Or you can just unmute yourself and ask a question.
Here's my hand.
Oh, okay, go ahead, Kath.
I'd like to ask Luke what scares him about AI.
Well, sorry, what's my what?
What scares you about AI?
Oh, what scares me? Well, so I think about it like AI is a tool, and it's a really powerful tool. And so, you know, the extreme analogy is, AI is unbounded in potential to people, like a very powerful weapon. And it scares me because when you build a really scary, powerful weapon, there is the chance that people are going to misuse it. That we're already finding a lot of chances where people are using AI to make propaganda and to try and create fraudulent voting and like break elections and undermine democracy and all these things. But what scares me is that it's enabling people who are bad people to do these things more easily, more powerfully. And what scares me is it's so easy to download this technology. It's just software. It goes on computers that it scares me that it's so easy. Nuclear weapons are locked up in government guarded safe storages. AI technologies are software that you can just download, and probably it's not as dangerous as a nuclear weapon. That's an extreme example, but the fact that it's just so easy for bad people to get their hands on it and there's nothing we can do to stop them, that scares me.
Okay.
That scares me too. Tom, did you have your hand up? Oh.
Yeah, go ahead and unmute Tom there.
Yeah.
Yes, a real-world example. I'd like to know your take on it. We have been in the past few months in a situation where a university in Europe modeled COVID-19 and what was going to happen around the world. That dictated a lot of decisions by government leaders across the entire world. Yet we found out now that that model was flawed. The professor who worked on it has resigned or been fired from his job. And it has caused literally major decisions to be made about shutting down economies. And we see some tremendous differences. Sweden didn't shut down. We have states in the United States who never shut down and others that did. And it seems to me that this is a perfect way that AI could be used to model all that data, to learn from what's happening in the 184 countries that have had COVID-19. And I'd like, Luke, what is your take on this? And why can't AI step in and handle this as a huge data modeling thing, and all the great minds in Mountain View and Silicon Valley to gather together and model this and get us some data and information and predictions that make more sense than it seems like. Now now the latest thing is about this model is that never let academics ever do models again for something that's important.
Sorry.
Is that it's come about is that never let them do it, and let's turn to the insurance industry and let the insurance industry do the models, since they're very good at doing actuarial tables and forecasts and so on. So Luke, what do you think AI can do for this, and can help us get out of this issue where we get forecasts up to 2.2 million deaths in the United States, and it looks like we're going to be under 100,000. So what's your take on this?
So that's a great question, Tom. I think it's a very salient example, and it's a fascinating discussion. I've seen right now I can't go on any social media and look at what other machine learning people are doing without hearing this exact conversation over and over. How the heck did this model get chosen, and all that. It's interesting to keep in mind machine learning or artificial intelligence. That the equation there is you have data that comes in and you have the correct answer along with the data, and then you get the rules that'll help you. So you want a rule to, predict whether shutting down or not will be helpful to your, recovery rate, or, will the cost of shutting down be more or less than the cost of not shutting down. But predicting those costs, we are now just starting to get that data set for different countries where all of those, inputs and outputs are lined up, where you can see, okay, this country shut down, this one didn't. But it becomes very challenging to make sure that the rules you end up learning, the machine learning algorithms can be very good at finding a rule that's very good at answering the question for the data, but very bad for, generalizing is the term. So one example of this is if you look at which teams won the Super Bowl back in, I believe, is the 70s and 80s. It might be 80s, 90s. The team, if the team from the NFC won versus the AFC won, the stock market close for that year would either be positive or negative. And this happened for over 5 years in a row. So if you were just saying, like if you looked at, the NFC team won this year, I'm going to put all my money in the stock market. The AFC team won this year, I'm going to take all my money out of the stock market. You would have made a ton of money for those 5 years. And if you give the model data on, this is the team that won the Super Bowl and this is how the stock market performed, it will pick out that rule. You can give it data on everything. You can give it, weather, you can give it the football teams winning, you give it all this stuff. It will find rules that fit, that answer the question. The problem is, if you did that in 2000, the rule doesn't hold. There's no actual rule. It's just as a what's called spurious correlation. And so the challenge is we have all this data, but we don't know which things are just coincidence. If you look at enough data, you can find coincidences in it without being able to, understand what's going on. So a lot of people are trying to build models, and this is what my company works very strongly around, is understanding, can we build an AI model that doesn't just answer the question, that doesn't find a rule that matches the past data, but we have a reason to believe that rule actually will hold true on the future data. And that's very hard. I mean, people have a hard time doing this, right, Tom? You have science experts who look at all this data on which countries are shutting down, which countries are having the highest deaths, and they're disagreeing with one another. The human experts, the most intelligent people out there, can't get up to the same page. Nobody truly knows definitively. All of these, there's no one right answer. I think some of the smartest people out there are saying we don't really know, we can only make an estimate. And so it's interesting to see that, like, computers, we can try and automate that process, but when the human intelligence can only do so well, it becomes very hard to beat that human intelligence with machine intelligence. And we, right now, like, there's also a matter of big data. So, when you have millions and millions of examples of something, so many, like, the entirety of Wikipedia, it becomes very hard for a person to go through and read all of that and learn from it. Whereas machine learning algorithms, they might be a little dumb, but they can go through way more data way faster than people can. And that's their big advantage right now, is that machine learning algorithms today can read through way more information than people can. And so the cases you see where machine learning algorithms are doing better than people at tasks are typically areas where you have millions and millions of data points, maybe tens or hundreds of millions of data points. Self-driving cars, each individual frame of the video that they take when they're driving around can be used as a data point for the machine learning model to train on. So we're talking, hundreds of millions of examples of things out there to learn from. Whereas, with this COVID situation, we only have a few hundred countries out there, and it becomes hard to draw the right answers necessarily out of it. What you said, so the last point, and then this is just, this is almost longer than the whole presentation at this point, but the point about not letting academics build models, I think this is something I really wanted to impress upon you guys. When you hear somebody say AI is going to ... I just encourage you to kind of like, do something like, tune it out, because a lot of people are very excited, but it's a very slow grind. People thought that computers were going to beat chess players back in the 70s. They thought they were going to beat them in the 80s. They thought they were going to beat them in the 90s. Well, they were right in the 90s, but it took 20 years longer than anyone thought. The original Dartmouth conference, it was a couple of the founding fathers, these mathematicians got together, I believe it was at Dartmouth, for a summer. They thought they were going to teach computers to read and write English by coding programs for one summer in the 50s. And this was just because they didn't know how hard it is. We are just starting to appreciate how intelligent people are compared to computers as we try and solve these problems. The things we take for granted, like being able to stand up and not fall over, we still can't get robots to do that properly. And and you do that from, before you learn how to speak. And then you learn how to speak before you even, you can't even do math, but you can speak and you can hear words. We can't get computers to, I don't know if you all have Alexa or one of these voice assistants, but it's I think most kids named Alexa can recognize their name a little bit better and can understand basic things like what's the weather outside a little bit better than today's most advanced Amazon.com software where they have all these research scientists. So it's still a long way off. So,
Well,
yeah.
I just want to check in with Tom. Did that answer your question to your satisfaction, Tom? And then Bruce has a question.
Yes, it did. It sounds like AI has a long ways to go yet, and
A long way to go.
in that we're not going to be replaced as humans tomorrow.
No.
It's going to be probably not in our lifetime.
Yeah.
I hope not in mine either. Hope not in yours, Luke. Thank you.
It's
Bruce,
interesting
do you want
because,
to, your question, Bruce?
Yeah,
Sorry.
I would think that the medical field would be a great place for AI, in that there are millions of papers that have been written of double-blind testing. In other words, the results of the testing are included in the paper.
Mhm.
So you have that aspect, the data and the performance, so to speak. And can you talk about how that application is going?
Yeah. So actually I live with a guy who does clinical trial coordination at Stanford. And I've learned a lot more about that field and come to appreciate how there's all these little challenges to working with AI in medicine. One of the biggest ones is the do no harm principle. So, when you want to do one of those clinical studies, you as a doctor have to give a really good reason as to why you think it's good to give people this drug or this treatment. And you get informed consent and all of this. Just now, there are some studies coming out trying to use machine learning algorithms to do diagnosis or treatment. But the problem is, you have to be really sure that you're not hitting one of those spurious correlations before you start actually, giving people a drug that the machine learning model, you trained it on 10 studies before, and it was able to predict which drugs were useful and which weren't before they actually did the study. So you think, wow, okay, for the 11th study, I'm going to let the machine learning model decide. But you have to really justify that decision, and doctors can go in and they can talk about the neural pathways that things go through, and they can talk about the theory of how a drug is actually working on and justify trying out this experimental treatment in a way that a machine learning model, even if it can predict the right answer really well, it picked all the correct drugs to out of this list of 1,000 studies, it picked the 100 that were the best. Even if you get to that point, it becomes very hard to kind of green light, okay, let's do a study on this drug. But people are doing that. There's some very fascinating work in understanding diabetic retinopathy, which is if you have diabetes, you are at a high risk of issues in your retina where you'll have eventually it'll cause blindness. And I'm not a medical professional, so I don't understand the exact functionality of it. But the way that this is diagnosed is they basically photograph your retina. You go into the doctor's office and they take a picture, and then an optician, an expert, goes and looks for these tiny signs of discolorations or problem areas. And they've been trained after looking at a lot of these retina images, which ones are to classify, is this a severe case, is this a mild case, or are they safe? And what's been found is if you take a bunch of these images that these medical experts have labeled, and you teach them to predict, to actually tell you which ones are diabetic retinopathy and which ones are not, they can do really well. And so what and what's happening now is that people are developing software to put in the hands of these experts. So it's not that you need the optician that they're getting replaced by a machine, but they get like kind of a spell check. They circle this part and they say this is diabetic retinopathy, and the computer says, are you sure? That I thought this one was healthy. Or it says, it'll actually find the region that it finds that is most that causes its prediction. So this is something my company works on, which is if I have a system that takes in an input, a drug type, is it going to work? Or take an input, an image, is it diabetic retinopathy? Or take in someone's a gene sequence and says, are they probably going to get this type of rare cancer? All those predictive tests, we think we can guess something very interesting and helpful medically. If we can have the computer say, okay, but this part of your gene sequence is why we predicted you have a cancer risk, or this bottom left-hand corner of the image is why the model thought this was diabetic retinopathy. That's the algorithms that I'm working on, and we've starting to see this in the last couple of years. Google has a team working on this. There's some startups that are actually deploying this technology in countries that have less regulation. There are actually places in China where you can get your diabetic retinopathy evaluated by a computer algorithm. And they use that to decide which, the people or the computer thinks have a really severe case, they send them right to the doctor. Whereas the people that, clearly have no case, they send them home. And the people that they're not sure, they send for the actual full evaluation. And so they're able to start doing these things. So those are just some examples of where it's breaking in. But the reason it's not happening quickly is because people want to make sure the do no harm, principle in medicine is really being upheld, and trust. This is what my company works on, is really hard to build in something that is just an algorithm. I mean, going back to Tom's example, you have this code that one person wrote without ever really explaining it to another person, being used to drive models. And because this person's a famous academic, people start trusting the output of that model without actually checking it. And you can run into some very scary situations and make decisions. It's horrible to make things like international epidemiology decisions around COVID, or make medical decisions around something that the model might not be quite right. So yeah.
Well, thank you.
Yeah, thank you, Bruce. That was you guys are just full of great questions.
Anybody else who's got another question? I muted everybody, sorry, because there was some background noise. So if you have a question and want to unmute yourself, go for it.
Luke, hi, this is Diane.
Hi, Diane.
Hi, I have a question. Could you talk a little bit more about the machine learning by reading Wikipedia and then being able to predict the words? And is that the kind of program that Google is using, like when you're using Gmail and it finishes your sentence for you, or is that something else totally?
Yeah, Diane, those are two really great questions. It's interesting. So I'm going to answer the second one first, which is that algorithm is actually a rather simpler and old school algorithm. And it's the people have been, other than Google, there are companies that use the same type of technology as the machine learning model that's read Wikipedia and can generate free text. But what Google does is they look for emails that look like the email you're writing, and they just find what other people wrote in that section. And they actually, most of the work on that feature is done in privacy. So, if you had a very unique looking email, they won't give you any suggestions, because you might, if you say, I'm going to meet you at 301 Arrowhead Drive, to give you the ... maybe you find out exactly what, I don't know if that's, Mom, you live somewhere near Arrowhead.
That's
okay. Everybody knows my address now.
But if 1,000 people get an email that contains the word,
see you later.
Yeah,
it's very canned. Yeah.
Yeah, and the replies all contain some version of sounds good.
Yeah.
Google can easily just match that. And so they actually have a matching algorithm more than a predicting algorithm.
Okay.
But what this model that read Wikipedia, basically, the high level idea of it is that for every unique word in the English language, we can create a sequence of numbers. Like if you like, basically you can create a point in some space, but it's not 2 or 3 dimensional space. It's like 1,000 dimensions. And so
Mhm.
another way of thinking is we come up with 1,000 different kind of concepts, and we give each word a different amount of that concept. And so there are techniques basically that if you give uh, a bunch of words in, we'll start by giving him random concepts, and then we'll try and use that random concept to predict the next word in a sentence. And then what happens is we do an error correcting stage where we go back and we say, okay, if we change the concepts a little bit this way, if we make this word's fifth concept a little higher, we get a better predictive performance. And we iterate over that. We repeat this process like millions of times until we've learned something where every word goes to a vector. Is a word to vec is the technology that it's called. That's actually so I kind of lied there that was the first technology that used reading all of Wikipedia. And the goal was to create kind of put every word in give it learn a set of concepts, which every word is composed of one of each of some amount of each concept. What later happened is they have a more complicated version of this where instead of feeding in one word and getting a concept, you feed in a sequence of words and you get back a sequence of these numerical representations. And the sequence itself is parsed in such a way that, the word, if I say this is not nice or this is not fun, the not and the nice being next to each other kind of share some information, just like in English. And so with this type of mathematical structure, we've been able to create a model that can actually translate a bunch of words, a sequence of words, into a sequence of mathematical representations, basically points in high dimensional space, or a vector of numbers where each number, a list of numbers where each number represents some amount of a concept. And by transforming it into this space, we can use the same type of technologies that stock prediction or some of these other economists use these techniques. Actually, fairly simple model to map from that representation to a prediction of the identity of the next word. And so that's the jump there. So we feed this, and what we found actually is if you just take in a sentence and you create a fill in the blank task, so not necessarily give it the first 10 words and predict the 11th, but maybe hide a couple of the words, and you can create one of those examples of you have data plus decision, right? You decide what to fill in the blank with. The decision. So you can crawl through, you can have a very simple computer program create these. Data is the sentence minus a couple words. Decision is the words that were missing. Tasks, and create this massive set of data plus decision, which you run an algorithm over, which does this thing where you create a mathematical representation of each word, and then you use that mathematical representation of each word to predict the next word. And they found, or predict, fill in the blank. We've found that if you use the entirety of Wikipedia, you just give it a ton of examples, we can actually machine learn mathematical representation of English words, or a function that maps a sequence of English words to a sequence of mathematical representations, which are actually, they have some structure. There's some very cool graphs that people do where they show that the mathematical embedding, the version of each word is close. So if you look at the word for king and queen, they're close to each other, whereas the word for dog and apocalypse are farther away. And so we've actually found we can create through giving a bunch of data and specifying some structure that we want in this mathematical version of words, we can create a mathematical version of language which has properties like nearness or addition. And so then we can define the functions of that. So that's kind of that might have been a tangent, Diane, of the nitty gritty of it. But what's found is once you learn these versions of the words, you can actually learn. You can split off that part that translates words to math, and then have a math back to words thing. And that math to words thing can be really simple. So you can have a very small data set, essays that you, Diane, have written, or the lyrics from your favorite song artist. And if you can use examples from that smaller set of data to learn that math to next word thing and actually create what's called a generating model of language in the style of that thing. And so, maybe I can dig up some examples where people have trained a neural network machine learning model to write words in the style of famous authors, or and you can give it a prompt, like I said, you can give it the 3 words and it'll predict the 4th. So you can start, I can't believe I dropped my banana, and then continue with Henry David Thoreau's writing style. And so this has kind of captured the imagination of a lot of people, and is an active area of research right now. So
Yeah, it sounds like interesting in the whole language arts field, who people who are matching AI with advancement in language arts, or so anyway, thank you. That's very interesting, that mapping. Thank you. Okay.
Lee has his hand up. Lee, I unmuted you.
Thank you.
Sure.
You might be interested to know that the first time that sort of algorithm was used was to create music. They take all the works of Beethoven and run it through a computer and say what note would follow what note. And those computer programs can write a sonata, whatever you want, that cannot be distinguished by an expert. They are perfect as far as the musicology is concerned. That was done back in the 70s. That was a fun thing to do back then. But anyhow, my question, you put up your 4 questions, and you said what scares you about AI, and you said about dangerous people getting AI. My problem is it's not the dangerous people that are going to get AI that's going to cause the problems. It's all the people who are doing things that they think people want done that are going to cause problems. The classic example being the automotive industry, whereas 40 years ago, we had assembly lines that had thousands of people. Now we have 5 people on that because they've all been replaced by machines. What do you comment?
Well, I'm sad to say that Luke dropped off, but it wasn't, don't take it personally. His screen froze, and I think he's probably trying to get back on. But let's see. Sure, anybody has to go. I totally understand. And Luke's back, so. All right, Luke. Lee had a question and you dissed him. But Lee, can you repeat that? And I know we're running a long time, so if anybody has to go, it's totally fine. But do want to give Lee's question his share. So, and Mary Alice has one too.
I don't know what.
I have to go too at the end of the hour here.
What time is it? 54. Okay.
So yeah.
All right.
So.
Okay, I'm not sure how much you heard, but basically my comment was you're afraid of bad people getting AI. My comment was it's not the bad people you have to worry about. It's the good people trying to do things right. And the example being the automotive industry, where 30 years ago we had thousands of people on the assembly line, and now we got 4 or 5 guys running the same plant. So we don't need people anymore. We just replace them with machines. And I wonder what your comment is that.
Yeah, Lee, I think that's dead on. I think this is one of the reasons I like to talk about the etymology of the word computer or calculators, because we've been doing this actually for hundreds of years, where we invent some sort of a technique or technology that puts people, intelligent workers, out of business. The big concern I think that you pointed out is when it happens so fast that somebody who's one day they're working on the plant and the next day it's all machines. What does that person go do? That person's out of a job. If you have a really intelligent math person who's being a calculator one day and then they bring in an adding machine the next, that person back in the day probably had other work. They were probably pretty smart and could do other things. Now if you're an expert machine shop person, there's a challenge. So it's difficult. I think there are a lot of things that can be done. Another nice trend is that a lot of times things called cobots, so robots that are cooperative, have been developed. And you see even in the automotive manufacturing, I believe Audi, for some of their cars which are more specialized, that they do fewer, they don't mass produce as much. They actually found it's cheaper to have a mix of people and robots kind of doing some things by hand. And so that's a trend that hopefully we can reinforce too, and find the areas where it's valuable to actually have man plus machine and the same number of people doing better work, or that type of thing. But yeah, no, it is worrisome, and it does make us wonder too. If you were able to automate everything that we consider work that requires intelligence, and make machines do it all, where do the people end up? And there's a lot of great science fiction. There's a lot of great philosophy around that. I'm no expert in either field, so I kind of have to defer. But it's a great thing to keep in mind and to think about and discuss.
Well, along that line, you of course know all about Turing, and he basically said that anything man can do can be done by a machine. What is your comment?
So I think Alan Turing is one of the most brilliant minds in the entire field, and so to critique him for anything is a little daring. But I would say that whether it can be done, the fact is, right now we're very far from it. We still can't teach cars to reliably find stop signs, and there are billions of dollars being pumped into basically making sure we don't screw up finding a stop sign a little bit more accurately. We're not at the level where we can imitate music. Given enough examples of Beethoven, we can generate something that looks like Beethoven. But the actual idea that created the musical genius of his first works, the Beethoven style, that we don't have computers generating new styles yet. Maybe we'll get there, but we're a long way off, and I think it'll be interesting to see.
Well, Luke,
Alrighty.
thank you. I learned a lot.